Okay, so hello. Let me just confirm if you guys are already on your computers. Just give me a thumbs up. Only one, two. What about the other two? Circle Mano and Mr. Aliana. All right, great. So all of you are already here. Okay, so that's it for the register to register the segment, and then the other way around. So memory to register and then immediate to register. So we also have this one, which is the memory to register. So it's just the opposite of this one right here. So memory to register, it could be direct or indirect. We also have segment register to register. So it's the other way around of what we had in here. Okay. So the same byte field will go to CH, byte field BX will go to CX, DS will go to AX, and then BS will go to word field. Okay. So there is just one thing that you guys need to worry about when using this let's say special registers right here. You cannot move a size of 32-bit into a 16-bit. Of course, it will give you an error, okay, because you're like trying to fit a 32-bit into a 16-bit. So it's like putting a car into a motorcycle parking garage. Okay, so I think it's a common sense that you guys cannot do that one. Okay, so of course, that will give you an error. But of course, you can do the other way around. So if it's small and then you're going to fit that one into a larger size, then it is possible because it can accommodate that small size. Okay, so I hope we're clear with that one. So the next one is Leia. So this Leia is specializing in offset. So this is similar with move. So it also move, let's see, a memory into a register. Let's see, a register to register, memory to a memory, or let's see, an immediate register to register. So they work pretty much the same. But this one is use initialize register with an offset in BX, DI, and then SI for indexing and addressing memory. Again, offset is the distance from this point up to this point. Okay, so we don't know the exact content, so we don't know what we're trying to let's say get, but we do know the distance, so we can use that one to get the data or to display the data. Okay, that is the main uh, functionality of this offset right here. So let's have an example. Leia EX and then EBX plus 8. So EBX plus 8 is the one that we're trying to pass or uh, have and then move that one to EAX. So we don't know the data of EBX plus 8. Okay, what we know is the distance. So EBX plus 8 right here is the distance from this EAX right here. Okay, so if you guys are going to notice or check this one, initially, of course, EAX doesn't have a value. Okay, so it's 0, 0, 0, 0. But EBX has a value, of course, since, of course, you're transferring a data and then it must have a value. Then let's just say that the value of that one is this one, 0, 0, 4, 0, 3, A40. And then plus 8. Okay, so we do know the distance, but this is, again, this is not the one that we are trying to transfer. Okay, so it is the distance from this EBX, that is the one we're trying to transfer to EAX. So you're going to add 8-bit. Okay, so that is why from here, from 4, 0, it became, where is that one? This one actually. This 403A48. Okay, so this is the data that we are trying to get. So this is the content or the let's see, the address that we are trying to transfer to our EAX. Okay, so as a result, of course, this EX now has a value of that 48. So just focus on the last value. From 40, it became 48. Why? That is because it has an offset of plus 8. Okay, so it ignored the first 8-bit. Okay, and then move after let's see, are reading those 8 bits, which is now this 1D, 3A, 4A. Okay. So really is able to follow so far on how we come up with this 4A. Okay, so let me ask someone again. Mr. Tanikala, what if EBX is plus 4? What would be the value of our EAX? Mr. Tanikala or Mr. Eliana? What if we have here EBX plus 8? What is the value of our EAX? Or Mr. Martinez or Mr. Pumano? Anyone? None? Did you na get? Okay, let's go back. If it's just EBX, okay, and then no plus 8, then basically the data of EX is as it's already this one, the 40. But if it's plus 4, then of course it will become 44. If it's plus 8, then it will become 48. If it's plus 12, then it will become 4C because C is for our 12. Again, A is 10, B is 11, and then C is 12. So did you guys get that one now? On why the value of EX, if it's plus 8, is 48. Hello? Are you guys still around? Are you guys even listening?
Yes, sir. Add lang pala.
Yeah, it's just the memory address. Okay, it's the distance from this EBX and then the one that you're trying to really get. Okay, so if there is no plus 8, it's similar with the move. Okay, you're simply moving the value of EBX to EEX. But since we're using Leia, we can use an offset. Okay, we can measure the distance from this EBX and then plus 8. Okay, then you are now getting the value of this 48 moving to EX. Okay, so just do take note that this is the address, okay, that we are transferring, not the data itself. Okay, sinabi ko lang data kanina para medyo maintindihan nyo. Kasi from data to data tayo, di ba? From variable content to a variable content. But here, it's the address. Okay, in reality, I don't know if you guys can see the in reality, in contrast, if you guys are going to move, okay, which is the real content, the main content of that one, EBX plus 8 will make EEX equal to 0 times 0012C140, which is 1. Okay. So registers are, these are the addresses, and then this is the real content, okay, the one that is stored in our memory, okay, which is this 0 times 0012C140. Okay. So note, data movement or transfer instructions are very common in assembly programs since organizing and controlling the flow of data is one of the reasons why do we need to program a microcontroller. Okay. So we have some example of interrupts right here using a move instruction. So again, just like what I mentioned in our previous meetings, interrupt is could be an input or it could be an error that needs an immediate response. So in here, we have we're going to talk two interrupts right now. One is that requires to read a character, so it needs an input. Okay, that is one interrupt, which is 01H, and then another interrupt is 02H. So if we have read, okay, if it's asking this an input, then we also have a display, of course, which is the 02H. So 01 for read, 02 for the display. Okay, so in this example, two common DOS interrupts, which is the int21h were used. So you guys will see a complete format of this interrupt later on. But there is also one thing that you guys need to worry. So 01h is for read, right? So of course, upon reading, it will store that data into a register. Okay, it will not display it right away. Okay, so this will be saved always to AL. Just do take note on that one. Okay, so if you're going to as an input, let's see from 01h, this AH right here, this interrupt right here, it will be always saved or stored to our AL. So basically, if your program is asking input, then it will be always stored to our EL. So you guys cannot use EL anymore because it's already uh, being acquired or being reserved by this read interrupt right here. Okay. Then after that, of course, it will be displayed. Okay. And then where is it being displayed? It is being displayed from the DL register. So EL and DL is now being reserved if you're going to use read and display interrupt. Okay. So this program accepts a character and display. So just do take note that this 01h will only accept one character only. So A just one, and then we'll display also one character for 02h. Okay. So before we proceed to the example, I just would like to show this one to you guys. We have a lot of kinds of interrupt in times 86. So we have 10h, 11h, 13, 15, 16, 19, 20, and then the 21h, okay, which is the 01 and then 02. So all of the discussions or explanations are already here, but we will not discuss this one anymore. So what we'll only discuss is the int 21h, 01, AH1 or 01, which is for read character, and the 02, which is to write the character. So that's all for now for this module. So we will have more interrupts later on the finals, but for now, just the read and display. Okay. So I hope we are clear with this one. If you guys have a question, just let me know. Okay, just ask the question right away. Okay. So we now have here an example wherein, again, that model small and then that stock 100H is a default setting or a fixed code. So you guys don't need to worry about this one anymore. Just copy as it is. And then that beta is for now, this one is empty. Okay, we didn't initialize or we didn't declare any variable. And then that code now is our flow of data or the algorithm or the operations that is being or that is happening here. Okay, so take a look on this one, move EX at data and then move DS EX. So this at data right here is this blank or empty segment. Okay, so since data is empty, then we're not actually passing anything. Okay, and then EX is empty. And then again, EX is being passed to DS. So basically DS is also empty. So don't you guys worry, this will not give an error. Well, in fact, just use this one all the time, even though your that data is empty. Okay, so this will be a good habit to display or to read what is your that data. Okay, so sometimes you can in some cases you don't really need this one, so you can remove this one, but as a good practice, just always retain this one. Okay, so that you are always reading whatever is the content of your data, just in case that it has already a value. Okay, and then move AH 01 again. This one now is 01H. So we are storing that one to AH, but in reality, it's being stored to AL first before being stored to AH. Okay, and then EL, which is the same with AH again, is now being transferred to DL. Okay, and then if we have read, of course, we also have display command or code. So we have 02H, which is being transferred to AH. But of course, we cannot do that one by the way. So we have to do this one, move DL to AL. So whatever is the value of your AL must be moved to DL. Okay, since that is the registry that we're going to retrieve the data that is being stored, okay, or that is being displayed rather. So after this display character, then we can now end the let's say the loop or the program. So this is also an interrupt. This is a type of interrupt. This 4CH. This one means to end your program with this command. Okay. So end is another thing, but this 4CH is another interrupt to end your program. So this is an indicator that you are already ending your program. So basically, this is a fix. Oops. Okay, let me just get this one. So this is already fixed up to this point. So you guys don't need to change anything with this one. And this is also fixed. Okay, or we could say permanent. And then this one is just a function to read and to transfer the data from EL to DL because that is the one that is required. Okay, from here. EL that is being used in read, and then DL that is being used in display. Okay, and then after doing that one, you're now going to display that DL, okay, on the page, which is the 0 to H. So read, store, and then display. And then this is just to end. Okay, and then these are the basic initialization. You are the initialization. Basic, I don't know what they call this one, basic structure, but yeah, it's just a fixed a code, so you guys don't need to worry about this one anymore. So you can just simply copy that one as it is, the same with this one. Okay, and then the rest of the middle depends on what you guys are trying to do. Okay, to be display a certain character requires an input and display that input, and so on and so forth. So are we clear so far? Okay, so I really hope so that you guys are getting this one. So just in case that you guys have a question, just let me know, okay? So let's now proceed to the next one. Again, this is a fixed code, so you guys don't need to worry about this one. And then in here, 01H is asking an input, so 01. And then in here we have, oh, wait a second. It would be better if we will try this one out. Pero na yata ako nagawa eh. What ba yun? Here, ELB, yeah, it is this one. So let's run this one. So again, it's asking an input from this 21H, this interrupt right here. So let's just put, let's say K. Okay. So basically, it already jumped to the display, which is here. Okay. Dito muna dapat, pero anyway, it already ended the program, but it already displayed the K. So this is the input, the first character, and then this is the display, the second character. And then another interrupt to end the program. Okay, as you guys can see, program has returned control out of the operating system, meaning the program has already ended. Okay, so if you're going to rerun this one, so again, it's asking a data. Oops, here it's asking a data from the 01, let's say letter H. As soon as I click H, it happens very quickly, of course. So this is our input, and then this is our display. So are we here so far on what happened right here? So again, it just it reads one character and display one character also. Okay. So we also have another one wherein the previous program displays the output key input on the same line with the input line. Okay, first character, second character, display it on the next line. Use DL0 AH interrupt. So this is another kind of interrupt, which is the buffer input. So DL is equal to 0 AH. So this one is using a line feed interrupt. Also use display string EL is equal to DL after execution. So basically what's happening here, yeah, then move next line. Okay, so this is already the code for this one. Okay, so I'm not really sure if it's talking about the next line, like we're going to have a notepad. Where is that notepad? Okay, so this is the first line, right? And clicking enter is another line, correct? So this is the first line, this is the second line, and this is the third line. Am I correct? Hello? Are you guys still around? Are you guys listening, or are you guys are not eating? Wala natin nakikinig. And then natin yung meeting. Alright. Okay. So anyway, so supposedly it will go to the next line, which if that is what I understood according from this module. Okay, so it should proceed right here. But what's happening on this code, okay, let's run this one. So as soon as I click the first one, balikan natin. Let's go back from the start. Reload. Okay, so we have the same from the start. We have here 0, 1 each. So it's asking an input, which is this one, the first one. Oops, then S. Okay, so that one was stored now to our BL. And then it is now asking another input, okay, which is this 0 AH, which was supposed to be on the next line or down below, but it seems that that next line is just a next character, okay, beside this character right here, okay. So instead of a by row, I think it's by column, the one that is being talking here. Because it was emphasized here that the previous program, this one here, displays the output key input on the same line. So meaning same line right here. But in here, to display it on the next line, so I think it's now talking this one, which is the next line. Okay. But in this example, it's not actually on the next line. It's still on the same line. It's just I'm asking another input. So if I click, let's say K, then the display is still on the same line. It's just that we have a buffer right here, or a buffer input, okay, before it will display whatever is that the value of that AH right here. So are you guys getting the idea so far?
Yes,
so what
sir.
I'm trying to say is it's not on the next line. I think hindi ko lang kung magkamali lang si Ma'am Suarez. It's not on the next line, but still on the same line. But this one is just again asking another input. So it's like a separator only. We're going to run this one. Whatever is your first input, okay, will be the one that will be displayed right here on the third character after clicking another character in the middle, or let's see the buffer input. So SN and then S. Okay. Let me just try this one out. Okay, so if you want to display the value of this DL, I think we have to because in here it's asking input and then it stored the value, but in here it's asking input, but it didn't save that value, okay, to somewhere else. So what we have to do is it using different DL will go to AL. Okay, I think that is the one that is not being saved. And then let's try to display that EL right here. 02H, but instead of AH, it's now AL. Okay, let's try this one out. S, and then another input is K. It is double the value of our AH. Give it a second. This is AH is already being used. And EL is also being used at the 01 each right here. Ano pa bang iba? BL, CL. So that we can display both character, the first one and then the second one. SK. See pa rin? SKSS. So it seems that this DL is now being stored to our EH, or I mean EL also. Okay, so basically they're using the same register, so we cannot retrieve the value of this one because the first one that occupied the value of AL is this AH right here. Okay, so going back here, whatever is the value of this 01H is being stored to EL, wherein it's already being used by this AH right here, unless ano bang iba? Unless it's not really 0 AH. I don't know anyway. Anyway, so yeah, supposedly it will go to the next line, but it's on the same line. So the buffer input is just another input, which is this one. And then after clicking that one will display whatever is the first input right here. So let me just bring this one back to its original form. There you go. So S, the first input, and then V is the buffer input. And then the last one is just a display of the first input. Okay. Anyway, that's it for this example right here for this supposedly going to the next line that it didn't go to the next line. Okay. Next output line. All right. So we have example 2 here, move instruction used in displaying ASCII characters. So in here we have the ASCII table, we have the decimal, the hex, and then the character that will be displayed. Okay, this well, I'm pretty sure that you guys are already familiar with this one. So 65 is always for the capital letter E, and then 90, what is the small letter E? 97 is for the small letter E, and then it's now incrementing. Okay, and then we also have the special characters right here, starting from maybe 33 only. Okay, 33 and then onwards up to 40 right here. Okay, because right here this now start of heading and so on and so forth. So these are non printable characters. Okay, so we have an example here. again, we have this code right here, which is fixed, but we don't have the code right here. This move ex at data, move the ex, because our that data is empty anyway. So you can remove that one, or you can just simply put that one. So both of them will give you the same result. Okay, but for here, it go directly to move DL4. So we're passing the value 4 to our DL. So if it's not ending with H, okay, or B, it only means that this is an ASCII code, or a decimal rather. Okay, so that decimal will be converted into something else, which is, let's see, end of transmission. Okay, and we have, of course, we have read right here, and then we have a display right here, and then we also have another moving or reading of a data right here from 65 going to DL, or 65 is a decimal character, which is letter A, and it will be displayed, or it will be stored first to our DL, and then will be displayed afterwards, which is the letter E. And then for CH is just to end our program. So let me just check if I already have the code for that one. I think it's this one. Okay, so initially it's 4, and then display 65, which is A, and then display, and then to end the program. So what you guys will see right here, if it's a non-printable, may mali, may mali. I think hindi ko na-isip. Kasi special character na to, I think 70 plus kanina. Save, Emily, and then run. Wait a second. 4, and then A. Why is it displaying naman? Let me just try to change this one. What about if it's 2? Two is a non-displayable character, or non-printable. Four is an open parenthesis. Yesterday, when I was testing this one is actually a diamond. Okay. And that is the symbol of a non-printable character. I don't know what happened, but it became an open parenthesis, or an open bracket rather. What about if it's 7, Adele? It's a sound, which is a bell sound. Okay, you can display anything. But 4 is an open bracket right here. Okay. Anyway, so if it doesn't end with H, that only means that it's a decimal, wherein it's getting a data, or going to display a certain character. So if you want to display, let's say an open parenthesis, or let's say percentage 37, then we can also do that one, of course. Okay, a percentage, and then 8. So 97 is for small letter A. So we now have a percentage on the B. So are we clear with this example right here?
Yes, sir.
Okay. So 4 is I don't know if it's a bracket. Okay. But yeah, it's an open bracket. And then we have another example of move right here. How many minutes more do we have? Less than 1 minute. Okay, and then we still have